Welcome to another video, guys. Today I'll be participating in Biweekly Contest 105. As you can see on the screen, let's go. Hmm, it's taking a little longer. What's happening? Buy two chocolates. Okay, let's buy them. A bit of brightness. We given an integer array prices representing the price of various chocolates in a store. We're also given a single integer money consideration amount of money. You must exactly buy two chocolates in such a way that you still have some non-negative leftover. You would like to minimize some of the price to chocolate you buy. You'll have leftover from buying the chocolate. There is no way for you to buy without any debt. Return money. Okay. Must be non-negative. Oh, I don't know why this question is even here. It should be greater than 2, right? It says 0 and 3. I don't think I did anything wrong. This extra character in a string. Are you given a zero-indexed string S and a dictionary of word dictionary? You have to break S into one or more overloading. Let's check. Yeah, one or more non-overlapping substrings, such that each substring is present in dictionary. There will be some extra characters in each S which are not present in any of the substring, and the minimum number of extra characters left over if you break up S optimally. So the size is, as you can see, it's very less. Uh, there's one problem. Otherwise, I would have done. Um, it matches with lead. Can we do recursion here? I think recursion would be a better option. I guess the length is only 50. I'm looking for a better approach. Something which is better than um, recursion. Mhm, mhm, mhm. Let's try doing recursion. Oh, let's leads code. There's one extra character. So basically, we can either start from here, we can start from there, we can start from there, there. Um, yes. No, basically, we're doing. If we're doing recursion, we'll take care of that. Recursion. So the index that we're going to pass is I is zero, sorry, and the string will pass text as well. And I think we'll have to pass string as well. And this is set. And we have to maintain count as well. I think we have to so initially count as 0. And is greater than equal to and will return count. This is the base case. Otherwise, um, yep. So if we have come here, yeah, that means we've already checked one possibility. Now I'll check for the possibilities. Um, do we have to pass a string as well? No, we passed a string, but we did not receive it. A reference? Um, no. I hope it doesn't really. Um, this is what I think I have to do. Maybe I could be wrong. Let's check. We'll debug. 5 and 13. This is much. In that case, we found a word. Oh, even if we did not find something, we'll still want to do that. Right? Yes. Know what's happening. Oh, should be I minus n. Bit late. Why are we sending half them? Send nothing. Oh, what's happening? Well, this is now backtracking and it will definitely TLE because 2 to the power 15, 50 is too much. I think I'll have to drop this idea and think of a better approach. Mm, and the other constants as well. If we probe the string optimally such that they are non-overlapping, we'll have minimum number of leftovers. If we decide to divide it here, we found a word, so we don't have to look for it, or we have found something, so we don't want to return that, right? We don't want to call that, but it's still wrong. Hmm. And we can certainly use DB to optimize it, but first of all, let's make the recursion work. Now we have to return 70 plus money. No, didn't work. We don't have to send Saint to them. Yes. Okay, so we have got the correct answer. It was just one here. CNT made no difference. It was this one. Now we certainly want to optimize it, so we can be 50 indexes. We'll go with 55. If DP of n, otherwise set DP of n equals to many. Let's check. 1 and 3, that's good. Are we good to go? I wish we don't get any. I think it will create an error. Yep, we don't have to. Even if I take it as something big, it should work. Yes. Anything else we can change? I don't think so. It's good. Cool. Well, I think it's one of the toughest second problem. I mean, DP for a second problem is obviously going to be tougher. I'm not sure. I mean, it can be done without DP as well. Maybe I couldn't figure it out. Maximum strength of a group. You're given a zero indexed integer array nums representing the score of students in an exam. The teacher would like to form one non-empty group of students with maximal strength. where the strength of a group of students of indexes I0 up till Ik is defined as, sorry about that, nums of I0, I1 up until Ik, and we're multiplying them. Return the maximum strength of a group that teacher can create. What is that? Non-empty group of students with maximum strength. Okay, so we have to pick some indices and we'll have to multiply them so that we get the maximum output. So we'll basically have to, if I'm not wrong, we'll basically have to find a subset of nums which gives the maximum answer when multiplied. So we pick these many indexes, and when we multiplied them, we got something like this. I think it's a backtracking problem. What's 2 to the power 13? Wait, 92. I think we'll have to try every possible combination. So it's 9 to the power 13. So basically, we'll have to use long. Yes, it's backtracking. Let's use long. That's a good habit for a question like this, to create every variable as long, even when it doesn't have to do anything with that. So what we'll do is, okay, we'll just try the iterative backtracking approach, subset formation approach. Non-empty, so we'll just ignore this, and let's take temp initially as one because we're going to multiply them. Maxi is initially, we'll have to find maximum, right? And when no, it's gonna be a lot less than that. I'm not sure about that, so I'm doing this. Multiply maxi with -1. And if I will just check the bits when I is right shifted by j, and if it turn out to be a set bit, we'll include that nums of j. Well, if it's this, it will be a lot easier. It's definitely a lot easier than the previous question. Yes, definitely is. Does not make any sense to be on the third position, but they almost have same number of solutions. Let's check how we are doing. Okay, not too bad. I took a lot of time on the second problem, but we're doing good. My submissions. 44. It's probably easier. Are you given zero index to integer randoms and you're allowed to traverse between its indices? You can traverse between index I and index j. Index I shouldn't be equal to j if and only if GCD of them is greater than 1 with GCD. Yeah, ठीक है. Your task is to determine if for every pair of indices I and j in nums where j is greater than I, there exists a sequence of traversals that can take us from I to j. Return to if it is possible to traverse between all such pairs and likely possible wise. Okay. Mm-hmm. For every pair. Well, j being greater than I does not make any sense because this operation is commutative. Even if you replace nums I with nums j and nums j with nums I, it does not make any difference. Okay, so we have to find a path. It's a graph question. We can form edges between all those pairs and then we can check if they belong to the same component or not. Yes, where's my DSU? Come on, DSU. Oh, here it is. Wait. To form an edge, you'll have to go through n square pairs, and that is not possible. Um, yeah. What else can be used to do it optimally? 2 and 3 does not share an edge. 2 and 6 does. 3 and 6 does. Um, so a number, not necessarily. Can we connect all numbers to their prime factors? Yes. Yes. Up to what number? Up to 10 to the power 5. Yes, we can do that. Certainly. So we'll connect each number to their prime factors. We'll create an edge between them. Okay, that's cool. We'll have to get the prime factorization as well. Will this work? It's root n. It's going to be tougher because it's 10 to the power 5. We'll do the other one for prime factorization. I think I have another one. Where is it? I think it's this one. Let's have 4. There was some mistake with this function. I don't remember what. I hope I changed it. I corrected it. Then we use get factorization. It does factorization in I think log n or something. So probably faster than the previous one, which was routing with pre-computation, obviously. Now we'll call the function save, and I will create tree. So we'll pass the numbers as well, which is going to be how many nodes. How many nodes? Oh, up till 10 to the power 5. Yeah, and that will be fine. What else do we have to do here? Now we'll create an edge for auto and numbers. Um, we'll get the factorization. We have it stored in S. Now we'll create an edge between numbers that are stored in S, T, and I. Okay, we have connected them. We'll check the parent of first element of 0. We want all the elements to be equal to that. Okay, what kind of error? Heap buffer overflow. That's just fine. What's the problem with the buffer overflow? What are we trying to access? Okay. This should be into the power 5. True false true. I think we're getting this. It looks good, it looks good. Let's submit. No, don't TLE. This is better than TLE, to be honest. Okay, what's wrong? I said false, it said true. Okay, lost one. Which one is that? Which one was that? Is it 21 is not connected? Yep, this function is correct. Yep, it's exactly this one, and it's correct. So we got the prime factorization, and I guess we got it right. Then we join them. Prime factors of 21 is going to be 3 and 7. Right. Now one thing I want to do, um, I want to make sure that the parent is always the number that I'm inserting and not the one which is not inside. So I'll do one thing. Um, I'm setting it equal to resize 1. I'll make it initially 0, and I'll only put the size equal to 1 to the numbers that I'm inserting. Okay, it's still creating problem. It's problem. DSU is correct. I could have done it under 30 minutes, but I'm not sure what the problem is. And let's not break it. Let's see what we're getting. We're getting 21 for almost every number except 35. Well, for 35, we have 5 and 7. So it's connected. Why 50 is the parent? Then parent of 50 is 21. Oh, sorry, get parent. Oh shit, what a silly mistake. Find parent it is. No? Okay, cool. I hope it does not create any problem. As far as I can think about it, it's correct. True, false, true. That's actually what we wanted. And not really. Another wrong answer. This is bad. Probably not a hard problem to do. Let's change it up to 1 and check again. Now it changed. We don't care about This is just guesswork. Mm, Okay, this is giving correct answer, so let's try this. Will it pass? Why is it taking too long? Is my code too slow, or am I missing some cases? This one has probably over 100 submissions accepted. Well, for GCD to be greater than 1, they have to have a prime factor common to them, right? Yes. Oh shit, shit, shit. The hell are we doing? It should do the job, I guess. Because there's nothing wrong with the approach that I'm following. It's just silly mistakes I'm doing. And I did it again. And we do not care about what which number is the parent of which number. We don't care about that. The only thing that we care about is that the ultimate parent should be same for them to be in the same component. And that's exactly what I'm trying to find here. Wait, let me check. Um, take this thing. Do we have the code correct code here? To maxing. Yes, it's correct. What could be what could we be what could we be doing wrong here? Everything else is just perfect. I hope the factorization is correct. Let's take the smaller example. This one. For 39 we have 3 and 13. For 35 we have 5 and 7. For 50 we have 2 and 5, 3 and 7, 2, 3, 7, 2, 11, 2, 3, 7. Yes, it's correct. What could we possibly be doing wrong here? There are no Chinese people, so it's probably not the correct rank. We did save. We created DSU. Um, we found prime factors up to 10 to the power 5, which is according to this number. Is there anywhere we're using n? Because we are not using it anywhere. We don't want to use it anywhere. Just remove this. Got the number on its factorization. For them to be connected, to have a GCD of greater than 1, they should have a prime factor common to them. And if there is a prime factor common to um, each pair, then they have to have same parents in a graph. Well, I can't think of any edge case. Or is there? What could we be missing? Oh, we can go from I to J only if J is greater than I. We can't come from J to I. Oh, so her. Oh, no. No, 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 no. Then the whole DSU concept is wrong. And we'll have to make a directed graph. Oh shit. If J is greater than I, then we can go from I to J. This is where we're messing things up. It can take us from I to J, but for J we have no path, right? Yes, we have no path. From I go to J. We can do it in this manner as well, but what we will do is we will short them. Does that make any sense? No, but we still can't go backwards, right? That's true. So we'll have to have a directed edge. Um, let's do it then. Then no, but how will we determine? Suppose 5 is common. This 5 and this 10. And then from 5 we go to 10. Mm, wait. How do we determine the directions? Because we're using a mediator in between. Suppose we have two numbers, let's say a and b, where c is the prime factor which is common to a and b. So according to question, there's going to be an edge which is like a to b and then b to c. But we have a and c in random order, but we know the b. So how will we determine the edge? Because it's not just a and c which have a common edge to b. They're going to be multiple numbers. Um, no, it's trickier. It looks like it's trickier. Still not too many submissions. We're losing ranks as well. Yes. How do we determine the direction? The concept of prime factor is cool and it's applicable here. Um, What if we determine the direction from smaller numbers? We can go to bigger numbers. Okay, right. Well, we're talking about indexes here. What about the last element then? We can't connect it to any other element, right? So every other element must connect to that element. Well, for every pair, if you're going to draw pairs, then we'll have a smaller number of bigger numbers. So I think direction does not make any sense because we'll have to find a path from either I to J or J to I. So instead of finding a path from J to I, we're finding a path from I to J, which is similar. Now it again comes back to something that we're doing wrong. But what is it? No, I think this will come into play. This will definitely come into play. This thing especially. Because if we want to go to, suppose we're standing, suppose I and J are 2 and 5. We want to go to 5 from 2. From 2, we found a way with which we can go to index 7. Now, from 7, we found a way back to 5. But 7 to 5 does not exist. 7 to 5 does not exist. No, what am I talking about? It's bullshit. If the GCD is greater than 1, then there is an edge and there is no direction. The only condition is that I and J shouldn't be equal. That's it. What possibly we could be doing wrong here? This is not good. And I already have like three penalties and I'm still not able to solve this. I didn't even get to the issue, the problem that we're facing. I think I misunderstood this and wasted my time. This is not the actual problem, it's something else. The edges are indeed undirected and they'll have to be in the same component. What are we doing wrong? Everything looks right to me. It will take log x at max. This is near about 12, I think. 12 into 10 to the power 15, 10 to the power 16 operations. This is bad. For them to be in the same component, they should have same parent, right? The topmost parent should be same. DSA is right. I've used this template multiple times, so I believe this is right. Size is not a problem here, even if we set it equal to 0. No, size is not the problem. They have to be in the same component. They means all these number which is inside nums. What's wrong? This is rare. If I know the problem and I'm not able to solve it, it's fine. But in this case, I don't even know what's causing the problem. What is the cause of the problem? This is just random optimization. It's not going to make any difference. How many submission? 600 over 600. Oh, wait. There could be one inside. Oh, there's one inside. Oh my god. Inside there, there's one as well. I think that is causing the problem. One will then connect to every number. If there is one inside, will directly it impulse. Is this? How will I check? For one, we're not creating any edge. Oh, it could be this. It could be this. Is it? No. But for one. Oh. What if there is only one element? I can't think of anything else. So I'm just believing that this is causing the problem. And it was creating the problem. Now we're finally getting a different error. Now how do we deal with that? I could just avoid this, and instead of this, I could be using the order of rodent factorization. I'm not sure if it would pass this or not. 10 to the power 5, so root over 10 is going to be more than 10 to the power 7. Where this one. Was this creating the problem? Let's try and order. I've had too many penalties, I'm not even checking them. No, again, why? We're using some space here, then we're using some space here. I've had probably more than 5 penalties now. Now I'm left with only one option. We'll have to try this. Hope this works. No, what is wrong? Where are we using too much space? This DSC wasn't problem. Where can we avoid using some space here it is necessary. Okay, finally, what the? Seriously? This was the difference? Could you believe that? This was the difference. That's probably bad testing, or either the time limit is too strict. This is bad testing. This shouldn't cause any problem. How many penalties? Probably six or seven. One, two, oh my god, one, two, three, four, five, six, seven, eight penalties. That's bad. Even if I got it right, it's equivalent to getting it wrong. I'll be after this 1,000 people. Oh, because there's still 17 minutes left, I'll be even worse than them. Okay, it was a good contest. I think second was a great problem. Out of all these, if I think fourth was a good problem, if they had tested it properly, I would have gotten it correct in maybe like second or third submission. Overall, nice problems. Enjoyed it.